Hello everyone, and welcome to a short little video that is our first pre-lab of the year. So normally when we do labs in here, we're investigating some sort of phenomenon that I would show you. And we would brainstorm some things that we might notice about it that we could test. And then we talk about how we could measure those things, and then we go back to the lab and see if they're related to one another and how. This one's a little more canned because, well, it's the first one, right? We need to practice how to do labs in here. So this won't be, I don't think, a shock to anybody, maybe a few people when we get to the end of it. But if you think you already know the relationships, don't tell anybody. Do the lab. See what nature tells us is going to happen. So this lab is all about a special shape. Yes, indeed, the circle, right? So again, you've been told some things about circles back in one of your earlier math classes. You might even know a few equations that relate different things about a circle. Okay, but we're going to look at this from a more fundamental level. So again, forget what you've been told. Because in here, I try not to tell you things. I try to let you experience things and let nature show you what's going on. Right, so this is a lab that maybe you've done in math, but I doubt it from what I understand. So we're going to do it in here. Okay? Now normally, like I said, we would generate some variables we can test. For this one, because it's the first one, I'm just going to tell you. Okay? So the two things we are going to check about the circle lab are its circumference, which I hope you know is just the distance around the outside of the circle, and how it relates to its diameter. This is technically a chord that passes through the center of the circle, the length of that chord, right, that passes through the center. It's called a chord generically if it's just from one edge of a circle to another. A diameter is a special one that goes through the center. Now again, you may think you know the relationship in the equation already. Forget you know it. Let's see what nature says. So once we have our variables, we create a purpose. This will usually be on the lab sheet that I would give you to work with. Our purpose is to create graphical and mathematical representations of the relationship between the circumference and the diameter of a circle. This first part of the sentence is pretty much what we use all the time. We are going to make graphs, and we are going to turn those graphs into mathematical representations. Those are two big words which essentially mean we're going to build an equation that we can use to make predictions. And then this is what we're looking at. Relationship between circumference and diameter of a circle. So we are going to look at a bunch of circles. If you're in class, right, we'll look at these circles here. If not, I'll give you some separate instructions. Okay. But when we look at and measure the circumference and the diameters of these circles with a measuring tape, we need to gather that data up. And in physics, we usually gather our data up by putting it into some sort of data table. Note that a conventional physics data table has column headings across the top, which are the names of the variables being measured and their units. So I would ideally like you to measure this in centimeters if possible. Our measuring tapes can be done in centimeters. Right? You can also, really you can measure it in anything as long as you measure them in the same thing. It's just a little harder to use the English system. We tend to use the metric system in here. Notice we're measuring them in the same thing. I don't want one in meters and one in centimeters, right? There's centimeters both ways. These little squiggly lines here just meant that I couldn't fit my entire data table on the screen and make it big enough to see, so it's a broken data table. But it's going from 6 objects, all right? I'd like to see 6 circles, right, of different size. You are going to measure the circumferences and the diameters. You are not going to calculate anything. Right, in this lab. We are measuring and letting nature tell us what's going on. So when we're done with these 6 objects, right, and we filled in the data table, we're going to look at the data. Now, you might be able to see a relationship. You might not. It's hard to do that with just a column of numbers, right? Even though they're real quantities that mean something still. So we have something that we often use, again, in science in order to perhaps help us identify the relationship, and that is making a graph. In here we make a lot of what are called scatter plots, right? You're plotting data points. So the next step, and you'll see this on the lab sheet again, is to make a graph. You should title the graph. I would suggest something like circumference versus diameter. You usually go vertical axis versus horizontal axis is the convention. You have to label the axes. And notice here, there is a reason why I chose circumference on the vertical and diameter on the horizontal. There is some rules of thumb that we'll talk about in the next few days about which variable to put on which axis, but we'll get there. In this case, just make your graph this way for this one. All right, it helps us to identify what the slope means and things like that. So circumference on the vertical, diameter on the horizontal. You're going to make one by hand. Now this will be the only one I'll make you make by hand pretty much all year, because I'm going to give you a program that we can use to graph inside of, which is made to graph and do all sorts of things that we want to do with it. But we'll get to that in the next few days, right? So we're going to start out by making a graph by hand. So you do have to scale the axes. When scaling axes, I would suggest you put a 0, 0 down here in the corner for this lab. Okay, put a 0, 0 in the corner, and then go from there. When you scale, the scale needs to be consistent. Every line has to be worth the same amount. Right? You can't have every line worth 2 and then every line worth 5 later on, because that gets way confusing. The scales don't have to be the same. Right? You could have a horizontal axis where every line is 2 centimeters and a vertical one where every line is 5 centimeters. You can choose your scale. So what scales do you want to use? One that makes the data fill the graph as much as possible. You don't want to shrink it in the corner, or you don't want to shrink it against one of the axes, because then it's hard to see, is it a straight line or is it some sort of curve? So you want it to be big. On the program we're going to use, there's actually a button you can choose, and it auto-scales it. Right? And it just kind of blows up the data to fit the screen. But when you're making your own scale, kind of put some thought into it when you make it. Highly suggest working with pencil at this point so that you can fix it. Right? So you're going to plot your points. Okay, that's what we want to do today, all right, is measure the circumferences and associated diameters of our 6 circles. Again, measure, don't calculate, right? And then create a graph with a title, axes, units, and a nice scale on each axis so that we can plot our 6 points. You don't have to write their coordinates next to them. That's in the table, right? You don't even have to label them 1, 2, 3, 4, 5, 6. Just plot the points. Don't connect the dots yet. Don't do anything but plot the points. All I want is a scatter plot, okay? And then we will talk about in our next discussion about what we're going to do with that and how we can use the graph to create a mathematical representation. Have fun measuring some circles.